We had a request to do the scheme in part 1 of fall 22 test 3. Answer the following questions 1 through 9. Yours is going to be similar to this. I changed these reactions up, changed the things that are being reacted, but it's going to look a lot like this. What base would give the observed result in step 1? Some base that gives a KEQ of 10 to the 15th. We got to think a little bit. Acetylene starts like this. And what's its pKa? 25. So the other product is some acid with a pKa of 40. How did I know that? 25 minus X equals negative 15. X equals 40, right? Right there. There's the logic. So what's the only acid you know with a pKa of 40 that resembles something on this list? Yeah, an amine. Don't put it there. HNHR. pKa 40, right? So the base that made that would be N minus RH, right? Base becomes this when it picks up H plus from acetylene. So which base looks like the conjugate base of this thing? Give me a letter. Like B is the conjugate base of an alkene. Oh, E, I misheard you, I'm sorry. Potassium methanamide, yeah. That's got the NH minus with a methyl on it. Perfect. And then step 2. So step 2 is going to be HC(CCC) minus plus bromine on carbon 1 to methyl on 3, 4, 5. And you're going to get this. Synthesis. Exciting stuff. 1, 2, 3, 4. 1, 2, 3, 4, 5 with a methyl there. UPAC says 5-methyl 1-heptine. Right there. So that's question 2. And pKeq in step 3. We have step 3, step 3, step 3, step 3. Step 2, step 3, potassium hydride on this guy. Step 3, H minus goes to H2 plus C(CCC). 1, 2, 3, 4, 5. All right. So what's the pKa of H2? 35, and pKa of the alkyne, pKeq, 25 minus 35 equals negative 10. AD. And step 4 makes product 2 when we react iodoethane. Iodoethane looks like this. Iodoethane, C(CCC) with an ethyl group over here and a 5-carbon group here. 1, 2, 3, 4, 5. UPAC says the non. We're not surprised. We had a hept, and now we got 2 more carbons. It's a non. Non-3-ine with a methyl on 7. 7-methyl non-3-ine. No, I need the alkyne with the lowest possible number. not the methyl group, the alkyne. And he was asking, should I go from the right to the left? And I said, no, because this number needs to be low. Product 3, we're going to treat that thing with BH3 and acetic acid. BH3 and acetic acid. This is the other way to make a cis-alkene. Okay. Yes, this is ACOH, in case you forgot. Acetic acid. You get cis-alkene. So on this question, you're going to find the molecule that has the same name as the previous one, except it's an ene now, and it's Z plus same name as question number 4, but ine goes to ene. I mean, every answer is ene. You can't mess that up, right? Every single answer is ene. So 7-methyl non-3-ene, and it's Z. It's BC. There you go. Well, you're making an alkene with the same skeleton as the alkyne, correct? So it's having the same name as the alkyne, except ine is going to be changed to ene. And you got to know this is the one that makes a Z. Whereas if we had like the sodium and ammonia reaction, instead of this reaction, then you'd be picking the same name but E. So you go for answer B. If it was the sodium ammonia reaction here. And there you go. Step 5, KEQ during proteinolysis. So you got to know a little bit about step 5. Step 5. Whoa, do I have 2 step 5s? Yeah, there's a typo. Yeah, I bet it was fixed somewhere sometime. I bet on another test it was step 5 and I forgot to edit it. There you go. So during step 10, there's a proteinolysis where C with a mercury reacts with sulfuric acid to become C with an H. Okay. And in this reaction, we're starting with an alkyne, so it's a double bond to C. Double bond to CH. So what's the pK of sulfuric acid? -5. And what's the pKa of an alkene? pKeq equals -5 minus 45 equals -50. KEQ is 10 to the 50. Big A. And then products 4. Okay, we have product 3 somewhere. This is product 3. Ozonolysis of product 3. Prod 3 is going to react with ozone and S with 2 CH3s. So you're going to get this. Plus this. You guys like the ozonolysis products, right? That's 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6 with a methyl there. 1, 2, 3, 4, 4-methyl hexanal. Do you agree? Look at the answers. They're on the bottom of the screen, bottom left. And this one's propanal. What's al mean at the end? I know it's looking ahead. Oh, I like that. I don't like it terribly, but there. I did it again. I got the paint bucket on instead of the pen. And I want it black. Al means what? Aldehyde. No ketones here. Yeah. So propanal is the first one, Roman numeral I. And 4-methylhexanal is the other one, IV. So I and IV. I and IV. Right there. Choices for 8 and 9. Oh boy. So we need products 5 and 6. Let's just get products 5 and 6. We'll worry about naming them later. 5 and 6. Okay, product 1. We had step 2 gave product 1. Product 1. And we're going to do the oxymercuration. So this is step 10. Step 10, you get your carbonyl there with oxymercuration. There's your red. There's your 5 carbons. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Good. So that's 10. And then reactions 8 and 9. 8, 9. I got to get this straight. Product 6 would be question number, product 6. That's product 6, right? I just got to keep it straight. Prod 6. And this is going to be prod 5. And it's the same layout except carbonyl on the other end. The hydroboration is the carbonyl on the other carbon. 1, 2, 3, 4, 5 there. And that's product 5. UPAC says 1, 2, 3, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I wrote 2 7s? Okay, yeah, that should be a 4, huh? Okay. So, product 6, 5-methyl 2-heptanone, 5-methyl heptuone. Heptuone makes sense? And guys, are you stressed out about how do I do these ketone names? It's 2-one every time. It's the second carbon. So, guys, if you've identified ketone, the nomenclature of ketones is not what's going to get you. It's having your methyl on the wrong spot. It needs to be on 5. 5-methyl heptuone, which was this one right here. So that was product 6. It's confusing. 6 is up here. 5-methyl heptuone, that was this, BD. And what about product 5? 5-methyl heptanal. Because there's no, it's an aldehyde. Yeah, 5-methyl heptanal. So B. There you go. Yeah, these are hard. I agree. Right there's a pretty good review for reactions. Here we go.